Hi, welcome along. Going to look at the basic maths of potential divider circuits, which hopefully isn't going to be too difficult, and then just going to look at how they can be used with an LDR, light dependent resistor, or thermistor as a control circuit. So let's imagine a kind of real world circuit. Let's call that 30 ohms. Call that 40 ohms, and call this a 12 volt battery, and ask ourselves the question, what would the reading be on that voltmeter? There are various options. The John Clinch approach, because I like to reuse things that I already know, is just to say to do this is two steps. One is to find the current in the circuit, and then the next step is to find the voltage here. So what we know is, and we can leave it as a fraction for the partial answer, V equals IR. The current around this series circuit is 12 divided by a total resistance of 70. The voltage here, let's call that VR, the voltage across the resistance we're interested in, is the current, which is 12 over 70, multiplied by the resistance of that resistor. And you get, let's just quickly do it on the calculator. So on the top we had 12 times 30, and on the bottom we had the total resistance 70, and we get 5.14 volts. Let's call that 5.1 volts. Now, you will see an equation called the potential divider equation, which I'm going to very quickly derive for you. My reservation about this equation is that there's a real risk in the exam that you do all the questions in class or at home using this equation, and then you get in the exam and of course you haven't learnt it, and therefore you don't have access to all the things that you practiced. But I'll trust you, either if you're going to use this equation, you've absolutely got to learn it. So we can do exactly what I did before. The current in the circuit is V divided by R1 plus R2. That voltage reading there is simply the current multiplied by the resistance, and that's sometimes called the potential divider equation. Can I have a look at quick look now at sensing circuits? So you might kind of have the idea, let's just talk about an LDR, because we've not talked about an LDR before. So a light dependent resistor is a resistor who, when you shine bright light on it, so you get more light, or light intensity goes up, resistance goes down. And if you've got the sort of brain where you remember things if they make sense, you can imagine these photons that are coming in ionizing, this is a semiconductor, ionizing extra atoms to provide extra electrons to reduce the resistance. Now, you might have thought, well, the simplest circuit I can build here would look like this. The thing you might not know is that generally the way that we control things in circuits is via voltage, and what we want is our voltage to change to trigger something else in the circuit. So you might, for example, imagine having a circuit where when the light level falls we turn a light on, like a street light or something like that. The problem is that when you shine light on here or remove a light, although the resistance will change and the current will change, of course the voltage doesn't change, because that voltage will simply be the same as the power supply voltage. So unless this has got lots of internal resistance, and that's kind of missing the point, the voltage doesn't change. So when we build a sensing circuit, we need two resistors. We need our resistor that's going to change and our resistor that's not going to change. So now imagine a couple of voltmeters. What happens when we shine? We increase the light level. If we increase the light level, this resistance decreases, doesn't it? So let's just put a little R here. That's going down. Therefore, the total current in the circuit will go up because there's less resistance. Much easier to think about the voltage for this component than that, because we've got the resistance hasn't changed. So we've now got more current in the same resistance, so this voltmeter reading goes up and that voltmeter reading goes down. So that means that if we wanted to turn on something when the light is bright, so let's imagine we shine light on here, that creates a rising voltage here, and then that could maybe unwind a sunshade out the front of a shop or something like that, or over some plants. Similarly, if the reverse must be true. If the light goes down, the resistance goes up. The resistance goes up, the current goes down. That means that voltage goes down, this voltage goes up. So you could use V1 to turn on a light if a room or something is getting too dark. One of these topics, actually, I think when you'll find getting onto the questions is probably a lot better than listening to me rabbit on about it.